Hi team, welcome to this video which is on negative and fractional indices. I'm just going to go through 4 key rules with indices and then we'll have a look at our key rules. So our first rule, the multiplication rule. Let's say I have some number x and let's say that's to the power of 3 and I'm multiplying that by x to the power of 4. I know that to get my answer I need to add the powers together and I'll get x to the power of 7. For the division rule, let's say I have x to the power of 6 divided by x to the power of 4, and I'm going to subtract my indexes, and I'll get x squared. My brackets rule, if I have, say, x to the power of 5 cubed, then I know that I need to multiply my powers, and I'll get x to the power of 15. And then the power of 0, if I have any number, x, and I'm going to multiply and I'm going to raise it to the power of 0, my answer will always be 1. Okay, so any number to the power of 0 will be 1. I'm going to need all 4 of those today. So let's have a look at negative indices. So let's consider a situation where we have, let's say, x to the power of 4. Actually, let's make that x to the power of 3 divided by x to the power of 5. Now, by our division rule, I'm going to do x. I'm going to subtract my indices, and I'm going to be left with x to the power of negative 2. Now, I want to think about and consider what this side actually means. So we don't just get distracted by the division rule. We've got a negative index as my answer, but what are we actually doing when we do x cubed divided by x to the power of 5? So let's write this in a different way. Got x times x times x, and that is all over x times x times x times x times x. So I've got x times it by itself 3 times over x times itself 5 times. Now I want to think about simplifying this. Now because I've got x's on the top and the bottom, I can start to cancel them out. So this x and this x will cancel out. This x and this x will cancel out. This x and this x will cancel out. And as I've got no x's left on the top, I'm going to be left with 1. And on the bottom, I've got x times x. I can rewrite that as 1 over x squared, because I've got x times x. And that means that I can easily write x to the power of negative 2 as 1 over x squared. Okay. Now we're going to look at a few examples, but the key thing here is this negative is going to be that we flip the fraction. Okay. And the fraction might not be really obvious, but I can write this as x over 1. And then I'm going to use this power, okay, to square, or to apply the power, okay? So let's look at a few examples. Let's write down the value of these 4 examples. Okay, and the question will always say write down the value of, because you should be able to write them down quite easily. We'll start with the first one. 3 to the power of negative 3. Okay, that's going to be the same as 3 over 1. So I'm going to write it as 1 over 3. And then it's going to be cubed. Okay, 1 over 3 all cubed. Now it's important that we cube all of it, even though our answer will be nice and easy to see. But 1 over 3 all cubed is 1 cubed, which is 1. divided by 3 cubed, which is 27. So 3 times 3 times 3. And that's my answer there. The second answer, 7, it's over 1. So I flip my fraction, I've got 1 over 7. And then it's all going to be squared. 1 squared is 1 over 7 squared, which is 49. Okay. Now, this makes it clear why we need a fraction involved. We've got 1/2. My negative means I'm going to flip my fraction. I'm going to get 2 over 1. And then I'm going to put it to the power of 4. Okay. That's 2 times 2 times 2 times 2, which is 32, over 1, because 1 to the power of 4 is 1. And I can just write that as 32. Lastly, I've got fraction to negative, so I'm going to flip the fraction and then square it. And then I need to square the numerator. 5 squared is 25. And then I square the denominator. 3 squared is 9. Okay. I want to check if I can simplify it, but for this one, I can't. Okay. Oh, I've just realized I made a mistake. It's not 32. It's 2 times 2 is 4, times by 2 is 8, times by 2 is 16. One too many 2's there for me. Sorry, so it should be 16. Okay, so 2 to the power of 4. So double check your powers. You can get a little bit confused, but yeah, 16 over 1, so 16. Let's have a look at fractional indices. Okay, now again, we're going to look at where they come from, where we can kind of get them from. So our fractional indices. Let's consider a situation. Let's use a number this time. I think it might be slightly easier. Let's say 9 to the power of a half. And let's say I want to times that. Let's say I want to square that. Okay, 9 to the power of a half squared. Now, I've added in this half there, okay, because I think it's important for us to try and see what we can do. But 9 to the power of a half, my multiplication rule with brackets means I'm going to do a half times by 2. And so I'm just going to get 9. And that would be 9 to the power of 1, which is the same as 9. Okay. So I've got a situation where 9 to the power of half squared gives me 9. So I want to think, well, what does 9 to the power of a half equal? And we can probably work this out ourselves. What number do I square to get 9? We should remember that it will be 3. So what then does this mean? This 9 to the power of a half means that I'm going to do the square root of 9, which is 3. Now, the important thing is this denominator is here, okay? Now, we don't normally write that for a square root. But for instance, and we're going to look at this in a second, we can then suggest, let's say, 27 to the power of a third is going to be the cube root of 27, okay, which in this case would also be 3. Okay, but the denominator here will tell us what root we're using. Let's look at a few examples. We're going to write down the value of these. Now, 9 to the power of a half, we've looked at that already. Okay, so 9 to the power of a half is the square root of 9, which is 3. 27 to the power of a third, you can tell I've got some favourite ones we've also had a look at. But I'm going to write the cube root like this, and then I can use a calculator, or with this one we should be able to potentially do it. That one is also 3. 3 times 3 times 3 is 27. Now, a slightly more complicated one where we've got a fraction involved, where the number on the top is not a single number. Is not 1. When we have one like this, we can write this example as 27 to the power of a third squared. Okay, we don't have to write this step. This is just to show you. 27 to the power of a third I know is 3. And then we square it, and we'll get 9. That means that if I've got the denominator will be will cube root, whereas my numerator will then apply afterwards. Okay. So let's look at one more. 81 to the power of 3 over 2. That's going to be the same as 81 to the power of a half cubed. Let's do the bracket first. 81 to the power of a half is the square root of 81. Cube that, I get 81. 81. The square root of 81 is 9. So I get 9 cubed. That's 9 times 9 times 9. Okay, which is 81 times 9, which is a number I can't work out in my head. 720 plus 729, I think. I do have a calculator. So yeah, 729. Key thing then is that if we have any number, I'm going to put any number here, so 200 maybe, and let's say it's to the power of 5 over 2. Actually, I'm going to do it in general form. We'll use some algebra here. A over B. Okay, that's going to be the same as the b root of 200. So if that's 2, that'll be the square root. If it's 3, it'll be the cube root. If it's 4, it's the fourth root. And you can use a calculator to do that. And then all of it to the power of a. Okay, all of it to the power of a. Now, for complicated questions, you will have a calculator to do them. Sorry. For some questions, they're like up to probably this kind of difficulty, you will potentially be expected to be able to work out on your own. Okay, so do as many as you can without the calculator, please. Good luck. Any questions, let me know.